Today we're going to learn how to select points or any element inside a 3D object using geometry nodes, a powerful technique to apply any condition and animations. So let's do it. Okay, let's go to geometry nodes, create a new profile. I'm going to close this. And before we start building the geometry node, I want to show you how it works, what I'm going to explain you, so you can understand the why it's working. So if you understand how it works, you can apply it to your future projects. I promise you, if you give me some minutes, everything will make sense.
Remember, all I'm offering is the truth, nothing more.
So be patient, and I promise you that this will make you happy. So let's bring the pencil, and let's say that we have a cube. We have this cube. Don't judge me if it's not perfect. And let's say that we have some particles, some points around this cube. So, for example, I'm going to draw one here, one here, one here, and one here. And now I'm going to ask you, which points are inside this cube? Of course, you will tell me this one, because I can see it. But the real question is, how Blender knows which points or which elements are inside this cube, because he doesn't have vision. So to do this, what we have to do is to make any element, any point, cast a ray in one direction. So let's say that all the points cast a ray in this direction, for example. So each point is casting a ray in the same direction. This ray is a vector. And this line is the ray direction. Okay. Now, with these rays, imagine that these rays are really long, okay? We can know if these rays hit the object. So, which point is not hitting object? This one. Because if we continue with this, we can see that never is going to hit this object. So, this one, we can delete it, or we can ignore it. Okay. And now we have 3 points that are hitting this object. Where do they hit? Here. This one hits here, this one here, and this one here. Okay. Now, what we can get of this hit position is the normals. What is a normal? Remember, a normal is, for example, if we have a cube, I know it's not perfect, but it's the perpendicular line that is 90 degrees from the face. So each face have its normal. And if we have a more complex object, for example, like a UV sphere, all the normals have more or less like these directions. Okay, so the main point is that each face have a normal and a normal direction. And a normal is a vector. So, which is the normal, the hit normal of this hit position? So the normal, if this is a face, will be something like that. 90 degrees perpendicular to the face. So this line is the hit normal. Okay, and this is the ray direction. Okay, so we have this hit normal, and here the hit normal will be this line, and here the hit normal will be this line, because remember, always is in relation with the face. The only vector that doesn't change always is the ray direction. Okay, so now that we have these two vectors for each point that is hitting an object, we can create a relation. And to create this relation, we're going to use dot product. So we have this called dot product, that it's a node in Blender, but also it's used in Max. And basically, dot product, to sum up, says that when we have, for example, two vectors, so always calculate the relation between two vectors, okay? And when we have two vectors that they are perpendicular, so the angle is 90 degrees, this angle, the value of dot product, so dot product is equal to 0. Okay, this is the base. Now, what it says is that if these two vectors are aligned, so let's imagine that the two vectors are in the same direction, so aligned, then the dot product is positive, and it's 1. And if the two vectors are in opposite directions, so this one will be the same, and the second one will be, for example, this one, right? So if they are opposite, then the product is negative, minus 1. This is what does the product. It takes two vectors and calculates the relation based in the angle and the directions. And whatever we have in the middle, so for example, if we have something like that, this vector, and I don't know, something like this, so this angle, this dot product, more or less will be, I don't know, something like 0.7, something like between 0 and 1. And if we have something like, for example, this one and this one will be something like, I don't know, 7, 3, whatever, okay? Sorry, this is important, will be negative. So will be a number between this one and this one. And this one will be a number between this one and this one. Okay, we understand what is the product, right? It's not so complicated. And we have a node in geometry nodes that is called the product and do all these operations. So to see the product here, we have two vectors and we can get this angle. So we have this vector and this vector. And we can see that this angle, for example, is positive because it's less than 90 degrees. So they are really similar. So this one is positive. And this one, okay, the question is, which vector I'm using, this one or this one? First of all, this one we have to use it because it's the heat normal. So the real question is, this one or this one? It's the same, but the important line is the direction. So don't make the mistake I was doing at the beginning when I was studying this. I was thinking, okay, the angle is this one. No, it's this one because this is the direction. So this is the angle, okay? So this angle is more than 90 degrees. So it's less than 0 because it's negative. So this one is negative in the product. And this one, let's check it. This one will be from this one and this one. So this angle is more than 90 degrees. So that means that is negative, is less than 0. So it's negative. So basically, to know if a point or any element is inside an object, the only thing we need is two vectors, the right direction and the heat normal, and say that if dot product is positive, so it's greater than 0, for example 0.1, 0.2, 1, whatever, then means that the point is inside. That's all. That's the theory. So as you can see, what really matters here, because the right direction always is the same direction, is the direction of the heat normals, that always change based where they hit. And of course, if a point doesn't hit an object, then the heat normal is like 0, so the dot product, don't worry, it doesn't matter. So now let's see this with a project that I created to see it better. So here I have this project to see better all the theory that I explained you before. Basically, what we have is 3 points. These numbers are just the index. So the first point, the second, and the third. And these yellow lines are the rays. So the 3 points, all the points, are casting a ray in the same direction. And we can see it with this arrow. And this red number that we see is the result of dot product between the ray direction, this vector, and the hit normal. So right now, these points, these rays, are not hitting any object. So hit normal will be 0. That's why the result of the product is 0. And I create a condition to show it in red if it's not greater than 0. Now, if we have an object, I have an icosphere, and I'm going to move it. And let's see what is going to happen with these points and vectors and the dot product. So let's move it. And let's pay attention to this one. In the moment that enters, so maybe you're thinking that now it's entering, but look, it's not entering yet. But the moment that enters, this number changes, and it's positive. So this line is the hit normal. Now we can see that this ray is hitting just in the corner. So the hit normal is this vector, and now the dot product is positive because this angle is less than 90 degrees and it's positive. So the result is 0.5. That means that it's greater than 0. So that means that the point is inside. Let's see it with other points, moving this. And you can see that if I move this, the hit normal changes. Now we can see that this one is not inside and this one is inside. And we can see it if we move this, and here we can see the hit normal, and we can see that the angle is less than 90 degrees. So it's positive. Let's try to move it in the 0, and now we can see that both are inside. We can see the hit normals, and that the dot product is greater than 0. And in the moment that the points are not inside, or let's say it another way, the hit normals are in other direction, because let's try to see what happens here. We see that the rays are hitting. Okay, let's move this a little bit. We can see that right now, the point 0 and 2, the rays are hitting. We can see it with the hit normal. But the angle, remember, the important angle, remember, is the one that follows this direction. So this angle is greater than 90 degrees. So it's negative, the dot product. And this one also is greater. So that means that both points are outside. If you want to play with this project, because it's a bit complex, but follows the theory that I'm just teaching you. So if you want this project, because here we can add more points, look, I'm going to add more points. So now we can see better which points enter and not enter. You can get this project on my pattern. So don't worry, you can play to see how it works and to understand better this theory. So now that we know all this, let's apply this theory really easy in any project. Okay, now let's apply all the theory with a simple example. Let's create a grid and convert it in points with distribute points on faces. So we have a lot of points, and now what I want is to use a 3D object to say which points are inside of this object. So let's create an object. Let's use a cube, like the example, and let's make this cube transparent. I'm going to set this view, go to the shade editor, create a new material, and decrease the alpha, so we can see better the points that are inside. Let's give some alpha, something like that. And to see better this, I'm going to press N and go in options, and here select blended. Okay, let's come back to geometry nodes. And now what I want is to make these points cast rays. So how we do that? We have this beautiful node called Raycast that I have a wonderful tutorial explaining how it works. But basically, this makes that an object cast rays, like you saw in the theory. And we need a target. The target is to check if the rays is hitting the object. So the target will be the cube. So let's bring here the cube with object info. Let's select this cube and let's connect it here. And let's select relative, so later we can move this cube and get the information in real time. Now, to see if these points that are casting rays are hitting this object, we can get it with this, but what we want really is, remember, the ray direction and the heat normal is the only two things we need. And we need dot product. So let's bring dot product with vector math, select dot product that we know how it works, and we need the heat normal, okay, and the ray direction. So this is an input. We need to use a vector. Let's use a vector and let's connect it here. And now this is giving you this value that I was showing you before. So thanks to this, we can create a condition. And say, for example, let's use separate geometry. Let's connect it here. And we are going to say, let's use greater than in float, because this is a float. And we're going to say, select all the points that have all the rays that the dot product, remember, is greater than 0. Because greater than 0, remember, that means that is inside. This means that is inside. Remember, this is the heat normal, and this one is the ray direction. So, if this is positive, means that is greater than 0, then means that is inside. So that's why here we are selecting greater than, and we're going to leave this in 0. And now, if we connect this here, bam, the magic happens. So basically what is happening is that now is selecting, because we're using a selection, the points that are inside this cube. And if you don't believe me, I can move this and look. We are seeing in real time the points that are inside the cube. And thanks to separate geometry, let me select again this, unlock this, we can use the inversion to apply something. So let's use, for example, join geometry, and let's use two colors. So let's give two different colors. Let's go to shade editor. Let's create a new material. Let's call inside, and inside will be, for example, let's select yellow or orange. And let's make a copy, and outside will be blue, for example, the opposite color, something like that. So let's come back to geometry nodes, and we say that inside the selection, this one and this one will be outside. And now it should work, but it's not working because, let me think one moment. Why is it not working? This is working and this is working. Okay, something happens. Let me think one moment. I think instance. This happened to me before, but I don't remember why. Why this is working? Oh yes, it's working, but I don't know why with points cannot work with that. So what we have to do is to convert this in instance on points. So I think if we use instance on points, for example, UV spheres, it should work. Because remember, the points cannot be rendered. So let's use radius as a scale. And actually, I should apply this before this. So, sorry for that. Let me move this. And really important, if we work with instance, here we need to select instance. And now it's working perfectly, okay? So my mistake was to use points to apply materials. Remember, the points cannot be rendered in the render. So now we are working with points converted in instance, so with UV spheres, and we are selecting here instance, and we are saying the instants that are inside the cube painted in this color, and the ones that are outside, so the inverse selection, apply another color. And as you can see, if I select this, we can see in real time how it works. And you can apply any rule. You could say the ones that are inside, I don't know, make it bigger. For example, a scale instance, and let's make it bigger. Something like that, as you can see. So once you have the selection created, you can apply anything you want. And I promise you, this is going to work perfectly. And if you want to see with another example, let's use a more complex object. For example, let's use a monkey. Let's come back here and select the Susan. And let's apply the material to Susan like before, transparent. So now as you can see, if I make the Susan bigger, it's working perfectly. And as you can see, the only important thing here is to understand these nodes. This is the condition. It's really easy to apply these nodes. It's just 5 nodes. But the most complex thing was to understand how it works. The heat normal with the product and the ray direction. And don't worry, this value, it doesn't matter the direction, because the important thing is to cast rays in some direction. And the product will do all the work for you. So I hope you learned something new. And please, if you enjoyed this tutorial and you learned something new, I will appreciate a lot that you hit the like button and you subscribe. And if you want this project and the previous project, where I show you how this theory works, you can download them all on my Patreon, and more than 100 projects. So that's all for today, and see you in the next tutorial.